This lesson is overriding equations of circles. So you know some things about a circle. A circle is infinitely many points that are equidistant or equal distant from, they are equidistant distance, or how about just equal? So a circle is infinitely many points that are equal distance from the center. So every point on this circle is the same distance away from the center. So the radius of the circle, which is that distance that they are away from the center. A radius is the distance from the center of a circle to a point that is on the circle. So according to this graph, if we look at this circle on the graph, the radius is, and so we want to let's pick a radius that's useful for us. So let's use this vertical one, is 1, 2, 3, 4, 5. So the radius of that circle is 5, and the center is at -1, 2, and then 5. So -2, 5. Now we're going to need these things later to write the equation of a circle. So the equation of a circle has a formula, x minus h squared plus y minus k squared is equal to r squared. So what we want to do is we're going to take that equation. Now recognize that these are minus signs, okay? They're built into the problem, and that's going to affect how we give these answers, because it should have a minus, but when it doesn't have a minus, we need to manipulate the formula so that it does. I'll show you what I mean. So in this particular question right here, this, remember, it's x minus h squared plus y minus k squared is equal to r squared. So let's take that and figure out what the center and the radius are of this equation. So this piece is easy. It's easy to see that that h is 3. So the center would be 3. We're looking for hk. That's what our center is. So our h is 3. Now, if you look, this next one is y plus 11, but it should be y minus. Well, if I rewrote it, then it would be y minus a -11. So actually, k is -11. Now, the shortcut way to do that is if you recognize this is -3 and this is +3. This is +11 and this is -11. So the shortcut is always put it into the equation negative, opposite of what it was before. And if you take it out of the equation, make it opposite of what it was. Okay, and then the radius, so this is r squared. So r squared is 16, which means that r is, take the square root of both sides, so r would be 4. Now, in this next problem right here, notice that there is no h. There's no x minus anything. Well, when that happens, it's understood for that point to be 0. And then remember we said we're going to now take the opposite of that, so it's -5. So I'm going to use a k that is +5. Then if r squared is 36, r is going to be 6. The radius of that circle is 6. And this last one, the x squared doesn't have any other h, and the y squared doesn't have any k, so it is understood that that circle is at 0, 0. It has its center at 0, 0. So then if r squared is 81, that means that r would be 9. So let's take this then and let's use that idea. Let's take the equations from the graph, or the equations from the center and the radius from the equation, and let's use them to graph the circles. So in order to graph them, we need the center and the radius. So we're going to use our numbers here. There's our h and our k, and then this is our r squared. So my center is going to be -2, but it's going to be the opposite, 2, and -5 is your k, so we're going to write that as opposite. Your k is actually +5. And then your radius is, it's r squared is 9, so your radius is 3. So if I want to graph that, I would go over 2, up 1, 2, 3, 4, 5, put the center, and then the center of the circle is there, so then I have a radius of 3. So we want to put our dots at our north, south, east, and west, so that we can get our circle exactly where it needs to go, and then we'll draw in our nice circles. Okay, this next one, now be careful. Look here, this y is first and then x. That doesn't change, okay? It's still going to have k with the y, and it's still going to have h with the x. So it doesn't matter if those are backwards. So you're still going to do your center as hk, and you're going to get your h from your x equation. From the x part of the equation, it's plus 2, so we put minus 2 for h. And then it's plus 4 for k, and so we're going to put minus 4 for k. It's plus 4 in that y plus 4, and then we're going to put negative 4 for k. And then r squared is 16, so we're going to use r is 4. So I go negative 2, negative 4. There's my center. And then I have a radius of 4. So I go north, south, east, west, and put points. So that I get my good circle. Okay, so we know how to take the equation of a circle and get the center and the radius to then ultimately be able to graph the circle. So now let's do the reverse of that. Write the equation of a circle with the center at the origin. Remember that's 0, 0. So there's my hk with a radius of 8. So the formula is x minus h squared y minus k squared is equal to r squared. That's the formula. So since it's going to be x minus 0, it's just x squared plus, and then it's y minus 0, so that's y squared is equal to r squared. Well, r is 8, so r squared would be 64. Okay, so how about this one? Write the equation of a circle that has a center instantly, that's h and k, with a radius of 5. So we're going to use this same formula right here. So let's go ahead, and you can kind of start writing it knowing what it's going to look like. I don't know the signs yet, so I'm going to leave those off, but now I'll put them in. So h is negative 2, which means I put it as plus 2 when I put it back in the equation. K is 5, so I put it as negative 5 when I put it in the equation. Remember, when it goes into the equation or comes out of the equation, it's the opposite of what it is when it's the center. The radius is 5, so if the radius is 5, then r squared is 25. And so that is the equation of that circle. So we can do the same thing if we have a graph. In order to get this off the graph, then we need to know the center. The center is at 1, 2, 3, 4, negative 4, 3. There's your center. And then let's choose a radius that's easy for us to count. 1, 2, 3, 4, 5. Okay, so r is 5, and the center is at negative 4, 3. Now we just do what we've been doing. So it'd be x, and then it's negative 4, so we would write plus 4 in the equation. Plus y, and then it's positive 3, so we write minus 3 squared is equal to r squared, which r is 5, so r squared is 25. So there's the equation for that circle. So these last ones, what we need to do, I want you to see them on the grid so that you can figure out how to work with them. And then I'll show you that there's another way to do it. But I think seeing them on a graph makes it easier. So we've got negative 1, 5. That's where A is. And these are the endpoints of a diameter. And then negative 1, 3. Negative 1, negative 3. So these are the endpoints of the diameter of the circle. So I want to write the equation of the circle, which means I need the center and I need the radius. Well, the center, since that's the diameter, the center would be halfway. So that's 1, 2, 3, 4, 5, 6, 7, 8. So halfway would be 4. 1, 2, 3, 4. So here's the center. It's at negative 1, 1. That's easy to see. You can see it there. Then the radius is 1, 2, 3, 4. You can count that off the graph. So now we can write the equation of the line. So it would be x plus 1 squared plus y minus 1 squared is equal to 4 squared, which is 16. Now this last one is a little more complicated. You have to look at it, but we can see negative 2, 1. Is right there. That's C, and D is at 6, 3. So that's what the picture looks like. So here's what you want to do. You want to find, so we need the midpoint so that we can find the center. So first, let's find the midpoint because that's where the center is. So that's what we worked on yesterday. So we have x1 plus x2 over 2. And we have y1 plus y2 over 2. So negative 2 plus 6 is 4, and 4 divided by 2 is 2. 1 plus 3 is 4. 4 divided by 2 is 2. And if I had drawn it pretty, I would have probably seen there's 2, 2, there's your center. So I could have gotten that off the graph if I had drawn the lines nice and straight. So my center is at 2, 2. And then I need to know the radius. Now this is a little bit harder, but you can use the distance formula. Or in this case, I highly recommend that you use Pythagorean theorem. There's that nice little right triangle where this side is 1, 2, 3, 4, and this side is 1. So I can do 1 squared plus 4 squared is equal to, that's r, the radius, r squared. So I have 1 squared plus 16 is equal to r squared. So 17 is r squared. Now, I don't need to finish it and solve for r, because in the equation, I need r squared anyway. So I'm just going to stop there instead of solving for r like we normally would have if we were doing the distance formula. Now, you could still use the distance formula using those 2 points. I could have, if I had wanted to, I could have done 6 minus 2 squared plus 3 minus 2 squared, and I would have gotten the exact same thing. I still would have gotten 17 is r, the square root of 17 is r, and so if I squared that on both sides, I would get that r squared is 17. So your final answer then would be x minus 2 squared plus y minus 2 squared is equal to 17, and that's the equation of that circle. So you need the center and the radius to write the equation of a circle, and you